Hello everyone, welcome back to my YouTube channel. My name is Sunny and in this video we are going to discuss the detailed history of the generative AI. In the previous video, I already discussed about the roadmap of the generative AI. So if you haven't checked, please go and check guys, because that video is very important. If you want to make a career in the field of generative AI, so you must watch that a particular video. Your most of the concept, your most of the doubt will be clarified. Okay. Now guys, one more thing I would like to discuss to all of you. So recently I started my YouTube channel. I am preparing a lots of content and the playlist. If you have any suggestion for me, so you can fill out the Google form. If you want any specific content, any specific topic, whatever, right? So you can fill out that form. So based on that, I will get to know that, okay, so my audience, this is this is the thing basically which my audience want. And according to that, I will create my content and the playlist. So yeah, let's start with the video now. So in this particular video, we'll try to discuss the detailed history of the generative AI. So here I can write it down this. So we are going to discuss the detailed history of the Gen AI or the generative AI. Now before starting with the generative AI guys, let me explain you about the artificial intelligence, because see guys, one more thing here, I'm going to discuss each and everything in very detailed way. So this video is going to be a quite long. So what I thought that I will create a two part of this video. So this is the first part where I will discuss the primary history of the AI. We'll discuss the few deep learning concept and the method, and then in the next video I will discuss some advanced topic. Okay, advanced topic related to generative AI history. So here you will find out two part, and this is the first part of the video. So let's start with the AI. So what is the full form of the AI? So the full form of the AI is nothing. It is artificial intelligence. Artificial intelligence. Now what is the meaning of the artificial intelligence? What do you think? So here the intelligence, okay, the intelligence which we are creating artificially. Now here what is the meaning of the intelligence, right? So what is the meaning of the intelligence? So intelligence is the greatest gift of the God. Okay, so intelligence is a greatest gift of the God which humans got. I think you are getting my point what I'm trying to say over here. So intelligence is a greatest gift of the God which humans got, and that intelligence we are going to create artificially. How? So the simple answer, or the simplest answer over here, mathematically. Okay, mathematically, that's it, right? So here we want to create a mimic intelligence, or we want to create a mimic human, so that our machines also. So here we are going to create artificial intelligence, and that is nothing, that is a mathematical model and all. So we are creating it. Why we are doing it? So that our machines also can learn, okay, can learn, think, can learn, think, and apply logics like a human, right? So that is the main aim, or that is the main motto of the artificial intelligence. Now where this artificial intelligence is being used? So this artificial intelligence is being used in every domain. In every domain you will find out the use of the artificial intelligence. So let me highlight some points over here. Let me highlight some domains. So here let's say e-commerce domain. In e-commerce domain you will find out the use of the artificial intelligence. There are many chatbot and there are many systems which has been built up by using the AI. In the education domain also you'll find out the use of the AI. In the transportation and logistic, or in the transportation, logistic and supply chain also you will find out the use of the AI, right? So you will find out the AI based product. Then in the medical domain, okay, medical domain you find out the AI related product. Banking, finance, everywhere machine learning, AI, deep learning is dominating. Now here guys, if I am saying artificial intelligence, so what is the meaning of the artificial intelligence? So artificial intelligence actually, it is representing to everything. How? So this artificial intelligence actually, it's a superset. If I'm saying machine learning, so it is also representing to the artificial intelligence. If I'm saying deep learning, right, deep learning, it is also representing to the artificial intelligence. If I'm saying generative AI, right, if I'm saying the generative AI, so this gen AI is representing to the artificial intelligence. Means artificial intelligence is a superset. What is artificial intelligence? Tell me. As if artificial intelligence is a superset, everything is belonging to the artificial intelligence only. Means we are achieving the artificial intelligence by using the machine learning or deep learning or the generative AI, right? So artificial intelligence is having their own history, right? So I have divided this history into into the different year. So first is the early history, which is from 1950 to 1960. The second is the middle history, okay, or this was also the early history of the artificial intelligence between 1960 to 1970. So this is called the middle one, this 1980 to 1990 and 1990 to 2000. So it's a medieval history of the artificial intelligence, and then you will find out the modern history of the artificial intelligence. So here from 2000 to present. Now one more thing I would like to show you over here. So if we are talking about the artificial intelligence, or if we are talking about the artificial intelligence, machine learning, so you must have seen this type of architecture. So this is representing to the artificial intelligence. Now there is one more circle which is representing to the machine learning. Now there is one more circle which is representing to the deep learning inside this itself. Now inside the deep learning, actually you will find out the generative AI. So this pink circle is nothing, it is representing to the generative AI. So here this is nothing, this is my artificial intelligence. This green circle, this orange circle is representing to my machine learning. This is my deep learning, and this is my gen AI. So guys, for achieving the AI, for achieving the artificial intelligence, we have for achieving the artificial intelligence, we have a machine learning, deep learning, and the generative AI. At the end, everything is belonging to the generative AI. Means whether we are talking about the machine learning, deep learning, or generative AI, we are creating an intelligence. We are creating an intelligent model, which is able to take a decision, which is able to which is able to understand the pattern, which is able to predict something. Getting my point? I think yes. Okay. Now here, what was the early history of the artificial intelligence? So here, in this in between 1950 1960, you will find out that there was an invention of the rule-based system. There was the invention of the perceptron. I will come I will discuss it in a detailed way, don't worry, and I'm just giving you the overview. Between 1960 and 1970, you will find out the expert system, right? I will talk about what was the expert system. Between this 1980 and 1990, you'll find out the evaluation of the machine learning algorithm or the statistical model. Between this 1990 and the 2000, you'll find out the evaluation you will find out the evaluation of the deep learning techniques, right, or the different type of neural network like LSTM and the CNN. Then from 2000 to present, so it is completely deep learning era. Okay, from 2000 to 2024, like to the present time, it's completely a deep learning based era. So yes, in the detailed way, we'll try to discuss each and everything over here. Now if you're talking about 1950 and the 1960, so between this 1950 and 1960, let me highlight some sort of a point over here and see my main agenda to explain about the generative AI, to explain you the generative AI, the concept of the generative AI, which comes from the AI itself, which comes from the machine learning, deep learning itself, right? So the roots of the generative AI is nothing. The roots of the generative AI is deep learning, machine learning, and the AI itself, the earliest history of the AI. So here, if we are talking about the earliest history of the AI between 1950 to 1960, so there you will find out the very first thing. So the very first thing is rule-based system. Now what was the rule-based system? If I'm saying the rule-based system, so what is the exact meaning of this rule-based system? So here we are defining a rules, right? So manually we are defining a rules over here. People are defining a rules over here. Manually they are doing that. Rules is nothing, it's a condition itself. Like we write it down the condition, if, else, elif, and all, right? So that condition people are defining, and based on that they are taking a decisions. Okay. Now the second thing is what? The second thing which was invented between this 1950 and the 1960, which was the perceptron. Perceptron, actually it is nothing, it is inspired from the human neurons itself. I know. I think basically you have seen the image of the human neurons and the perceptron and the neural network, right? So perceptron was invented between 1950 to 1960, and the main researcher which was there, the main researcher. Let me highlight few names over here. The first name is very famous, Alan Turing. So Alan Turing actually it's a father of the machines, right? So automata and all, and even the artificial intelligence, like some sort of a models and the mathematical concept has been given by the Alan Turing. The second person was the John McCarthy. So John McCarthy, this is also amazing person. If you will read the history, right? So history of the AI, you will find out this guy, right? Now the third one was the Marvin McKinsey, right? So Marvin McKinsey was the third guy, which was the very popular. Okay, which is even like this researchers are having a great respect in the community of AI, because of this researcher, the latest invention which you can see, right? So because of this researcher only, they took the like step. Okay, they started at that particular of time, and now you can see the advancement in the field of AI and all. So rule based system, and there was the perceptron. So here let's say this is my neuron, right? This is my node neuron, or anything you can say. So here we have a different operations. So here is my submission and the activation function, and the information is coming to this particular node. So first there is a submission, this is also called a dot product, and then on top of this one we are applying the activation function. So and finally we are getting output. So this is the image of the perceptron. Now here we have one more term, and so the term is called, so this perceptron actually it was inspired from the human neurons itself, human neurons. Okay, so it was inspired from the human neuron. If you want to check with the human neuron, right, if you want to check the like image of the human neuron, let me show you that. So here I can search about the human neuron. So human neuron and perceptron, so you will get a clear cut idea. And guys, again I'm saying this video is in a like I recorded it in a detailed way, right? I'm recording in a detailed way, each and every each and everything I'm trying to include over here, so that you can understand clear cut meaning of the generative AI, artificial intelligence, machine learning, and the deep learning. You won't find out any such content anywhere in this particular in this detailed manner, right? So please be with me, and at the end each and every doubt will be clarified. If you are thinking this is slow, you can watch it in 1.5x or 2x also. Got it? Now here let me show you the image of the human neuron and the perceptron. So here's the image which is representing to the human neuron as well as to the perceptron. Let me copy this image and let me keep it to my blackboard. So here guys, you can see this is the image, the same thing which I was trying to explain you, and the same thing you can see over here. So this is a human neuron, or this is a biological neuron, and this is the perceptron, or this is the perceptron basically, which was created by the this guy. The guy name was the John McCarthy and the Marvin McKinsey. So here I think you got to know that what was the perceptron. Now here, if you are going to create a multiple hidden neurons, this is also called a hidden neurons. So let me show you the image of the multiple hidden neuron also, or the multiple perceptron. MLP image, or MLP means what? Multi-layer perceptron. So this is the image of the multi-layer perceptron. So one side you will find out the input, and other side you will find out the output, and in between you will find out the multiple neurons, right? Multiple neurons and the multiple layers. So we can have multiple layers. Okay, we can have multiple hidden layers, and that is called multi-layer perceptron. Multi-layer perceptron. Single perceptron means single unit, single neuron only, and multi-layer perceptron means multiple neuron with a multiple layer. I think you are getting my point. So this idea is clear, and this is also called neural network. This is also called, tell me guys, what is this? So this is nothing, this is called neural, this is a neural network, this is neural network, or artificial neural network, or it is also called artificial neural network. So whenever I am saying artificial neural network, you can take a reference of this architecture. I think the thing is clear to all of you. Now this was the earlier history of the AI. Now at that particular time, so when they have created this perceptor node. Now one more thing I would like to highlight over here. there was not such optimization technique, right? So optimization technique like gradient descent, Adam optimizer, RMS optimizer, adopt or the different ada grade and all different type of optimizer, it was not there, right? It was not there. So the optimization technique was not there. This perceptron and this like a multi-die perceptron, they were simply processing the information, that's it, nothing else. So then there is a one more there is a one more like thing basically which I would like to discuss here. So between 1960 to 1970 the export system has been created. I think many time you have heard about the export system. Now let's try to understand what was this export system. So if we are talking about the export system, guys, see, uh, primarily we have created the rule based system. Primarily we came up with the rule based system. Okay, then after the rule based system, see, this rule based system got little advanced. Now how it got the advanced? Now here actually for defining the rules, actually we are using some sort of a technique. So here we were using the decision tree, I think you know, no, right? Decision tree. So there we create a multiple stages, right? So in the decision tree itself we create a multiple condition. Programmatically it is nothing, it's a conditions itself, right? This decision tree, but in an effective way, in an effective manner, by using some sort of a mathematical concept. So for the defining the rules and all, so they have created a rule based system. Okay, and at that particular time in between this 1960 and 1970 they were using the decision tree. Now they were managing the knowledge bases also. Knowledge base means database where the information was there, knowledge base. They were using the semantic search also, semantic search. Okay, semantic search means to find out the same type of sentences, same type of data, right? So decision tree was there for defining the rules. Knowledge base was there for defining the data, for like collecting the data and all. Okay, so here we are having the semantic search, and the system basically which we got over there, the system was called the export system. So now if someone is going to ask you that what was the export system, I think you can clearly explain the meaning of that. And it was in the history of the AI itself, right? So it was in the history of the AI itself, this export system. Now the next thing was what? So in between this 1960, 1970 to 1980, so some machine learning algorithm, okay, few machine learning algorithm got uh, popularity. So here few machine learning algorithm got popularity. Now here if I'm saying machine learning, again it is representing to the artificial intelligence only. Okay, machine learning, what is the meaning of it? What is the meaning of it? Tell me. My machine is learning in some manner. Okay, my machine actually is automatically learning. It is automatically learning, right? So here this learning, okay, what is happening? Tell me. My machine is learning. Now here this is also a way for achieving a AI, for achieving a artificial intelligence, for achieving the artificial intelligence. Now how it is learning? So based on some mathematical equations, based on some mathematical formulas. Okay, based on some mathematical formula. Now here I discussed two things. So the first is what? The first is learning. The first is what? The first is learning. And the second is what? The second is mathematics. Okay, mathematics. So here if we are talking about the learning, guys, so we have two type of learning. Majorly we have two type of learning. First is called supervised learning. Supervised learning. And the second is called here unsupervised learning. Unsupervised learning. Okay, unsupervised learning. Now if we are talking about the supervised learning, again we have two type of problems, okay, which we can solve. So the first problem is called regression based problem. Regression means the target column which will be a numeric one. Target column will be a numeric one. Numeric means what? Numbers. Now here in this one, in the second technique, that is called classification. In the classification you will find out the target column. The target column will be a categorical one. The target column will be a categorical one. Category means categories, right? Categories, binary category, multi categories. Okay, now in the unsupervised learning actually, so here we don't have any target column in the unsupervised learning. Here actually what we are doing, we have a data, we have a features. Here we are making a groups, or we are making a cluster. Now based on what? Tell me. Based on what? Based on the So based on some distance based approaches and all. Again, it's a mathematical formulas and all. So based on some mathematical formulas, we are going to make a similar group, similar clusters over here from the data itself. And here we don't have any target column, and that is called a unsupervised learning. Now here we are talking about the mathematics, guys. So we have different topic in the mathematics itself. Now this mathematics is specifically it is called applied mathematics. Applied mathematics. Now here in this mathematics you will find out of various topics. So the first topic, very much important, linear algebra. Linear algebra, you will find out most of the topic, most of the concept of the machine learning, deep learning, it is inspired or it's a direct implementation of the linear algebra only. The second is calculus. Calculus plays a very important role. Okay, this gradient descent, minima, maxima, it all comes under inside this calculus itself. Then probability, it's a very important part, very important. Then the statistics. So this fourth thing actually is called applied mathematics, and these topics are pretty much important. So if you are starting to learn this deep learning, machine learning, data science, anything, so you must focus on these particular topic if you want to understand the mathematical flow, the mathematical formula of each and every algorithm. Okay, so if you are good with this if you are good with this four topic, then definitely you can understand every concept of the machine learning, deep learning, data science, anything, any algorithm you can understand, right? So this techniques, actually this supervised technique, unsupervised technique, or couple of algorithm, few machine learning algorithm, right? Few machine learning algorithm got too much popularity over here. So let me write down the algorithm name. The algorithm name was the linear regression. It got too much popularity. Logistic regression got too much popularity. Now here the next one, the KNN, got too much popularity. Naive Bayes also got too much popularity over here. So this algorithm got a popularity. And here guys, see the optimization technique, they were using the optimization technique like gradient descent and all, right? The gradient descent is also a very very old technique actually. And even this one also, if you will find out this linear regression and logistic regression, and even this naive Bayes, not this KNN, but yeah, this linear regression, logistic regression, naive Bayes, actually it's an old technique, old statistical method. And the foundation or the roots of this method, actually you will find out in between 1980 to 90, not 1980, basically 1900 to 1950, between this year. So this is a very old technique. And even this gradient descent also, so they were using the linear regression, logistic regression, and for the optimization they were using the gradient descent. So yes, till here everything was fine, everything was clear. And here this machine learning, specifically this machine learning, in the machine learning, what we are doing, in the machine learning specifically, we are training our model on a structured data, okay. Specifically we are training a model on a structured data. Now what is the meaning of the structured data? The data which we are going to arrange into rows and columns like this one. And in this rows and column also, the in the rows or column also, you will find out the feature whether it will be an integer feature or it will be a categorical feature. In the integer, numerical feature, okay. In the integer means for numerical feature. Now we have a different category of the numerical feature, like ordinal feature, or you will find out the like nominal feature, okay. Nominal feature, sorry, here I'm talking about with respect to the category. If we are talking about with respect to a numerical, so there will be continuous and the discrete. So let me write it down over here. There will be a continuous and discrete feature. So guys, here specifically it was working on this type of data, only. And yes, it's a way of achieving the artificial intelligence. Now guys, see the early history is fine between 1950 to 1960. So this comes inside the early history of the artificial intelligence. Now let's talk about the medieval history. So here this 1980, actually it is called the rebirth of the AI. So in this era, actually you will find out that in this particular era so the first thing, there was the artificial neural network, which was already invented in between 1950 to 1960, the perceptron. The second thing which was invented and which came over here, that was the back propagation, okay, back propagation in artificial neural network, and which was invented by the Jeffrey Hinton. So this Jeffrey Hinton actually, it's a godfather of the modern AI. It's a godfather of the modern AI, and recently he resigned from the Google AI itself. I think after 10 years. So for the 10 year he served to the Google AI itself, and then recently he resigned, and now he is worried about the AI. He is thinking now that what I had created, and it is like they are thinking that it's going to be a very very dangerous for the human, now for the human. Okay, so now there should be some rules and regulation on top of the AI, because the recent advancement which we have seen in the form of like generative AI, like chat gpt application and the other application, basically it was beneficial, but it was somehow it is not good as well, because it is taking lots of job, and which is a cause of the like lots of automations and all. And yes, because of the chat gpt and this type of model, like you will see that everywhere the layoff is going on, okay, in every industry, and the low level job is completely going. So yeah, that is the latter thing, basically definitely we'll try to discuss in our upcoming sessions and all. But yeah, so here artificial neural network, and then there was the back propagation which has been invented. Now one more thing which has been invented over here. The thing was the guys, tell me what was the thing over here. The thing was the RNN, right? The third thing which was invented over here, that was the RNN, recurrent neural network. So here it is a type of the artificial neural network only. And the artificial neural network, what they did, so they they attached one feedback loop actually here in the artificial neural network feedback loop. So they attached one feedback loop in the artificial neural network itself, and that become the RNN. And mainly they created this RNN for the sequence data. What is the meaning of the sequence data? Sequence data means like text data is a sequence data, audio data is a sequence data, audio, text. Okay, so in the sequence data there is like what is the sequence data? So in that we have some sort of a similarity. Let's say what I can do here, I can write down my name is Sunny. My name is Sunny. My name is Sunny. Now here this Sunny is related to directly to it is directly related to this name, and this name actually is directly related to me. So my name is Sunny. So there is some continuity in the data. Or you can understand now, even the audio which I'm speaking right on, as of now, or which is I'm speaking currently. So here you will find out some continuity. I'm explaining you each and everything in a completely sequence, right? Completely sequence. So here sequence matter. Here in the audio actually sequence matter. Getting my point? So this is an example, or the very good example of the sequence data only. Now in the 1990 you will find out there were so many things, right? So in ML, in with respect to the machine learning, there was some advancement, right? So you will find out the ADA boost, okay, this type of technique which has been invented in 1990. Then gradient boosting was there. Then the third one, basically SVM was there. Okay, the fourth one, gradient boosting, ADA boosting, SVM was there, and a couple of more technique you will find out over here, and the different ensemble architecture and all. And the fourth one, the very much popular, that is all LSTM was there. And the fifth is nothing, that was the CNN. Now here let me highlight this CNN. Actually this CNN has been invented by the Jan LeCun. Okay, Jan LeCun is one of the great researcher in the field of the like AI, in the field of the deep learning. So he has created the first like a convolution neural network. Now what is a convolution neural network? So we use this artificial neural network for the tabular data. Okay, we don't process this unstructured data like sequences and this images and all. Okay, by using this ANN, we never process. Why? Because if we are doing it, so we won't be able to find out the pattern which we want actually, right, in the like text, or in the like audios, in the images and videos. So for that specifically they have designed some other or some different type of neural network. So here the CNN, actually the CNN is nothing, it is specifically designed for the images and the videos. What is a videos? Tell me. Videos is nothing, it's a collection of the frame, it's the collection of the images. Now Jan LeCun, right, this Jan LeCun, like he has created the first network. The network name was a LeNet, right, LeNet. And they use the data set name. What was the data set name? The data set name was the MNIST data. amnest handwritten images. So they were using that this particular data, and the model name was the Linet over here, and specifically for the images and the videos. Now let me tell you how this CNN is different from the other networks. So if we are talking about the CNN, so guys, here also you will find out the ANN. Yes, ANN. So we have three things over here. First is convolution, second is pooling, and after the pooling you will find out flattening, and then ANN. Means convolution, pooling, and ANN, these are the three main component of the CNN. So here what I can say, guys, here I can say that this ANN, ANN, ANN. Okay, ANN means what? Artificial neural network. Artificial neural network, it's a fundamental unit of the deep learning. So everywhere we are using this ANN, and even the state of art architecture as well, and I will show you that, right? So ANN is a fundamental unit of the deep learning. So I hope so far everything is clear to all of you and this entire history. Now coming to the modern history of the AI. But before that, let me highlight one more thing. Let me give you the point, right? Let me give you the point that what is the difference between the classical AI? What was the difference between the classical AI and the modern AI? So that even you can explain in the interview also, if someone is going to ask you this basic question or this fundamental question. So we are talking about the classical AI. Actually, it was based on the rules, right? It was based on the rules, and the rules which human has decided, so it was based on the rules which human has decided. Now here in the modern AI, you will find out the algorithms, right? You won't be able to find out the rules, right? You won't be able to find out the rules. You will find out the algorithms. Okay, I shown you the different algorithm related to the machine learning and related to the deep learning. So machine learning wise, the typical machine learning technique, linear regression, logistic regression. Deep learning wise are different type of neural network like ANN, CNN, and RNN. Now here this algorithm majorly was based on the mathematics concept, right? So applied mathematics concept like linear algebra, probability theory, statistic, and the calculus. Getting my point, guys? So this is the primary, or this is a very important difference between the classical AI and the modern AI. I hope you got to know the difference and you got to know about the history of the AI so far. Now, what is the main agenda? Guys? So here the main agenda to understand about the generative AI. But before that, let me give you a few more ideas or few more knowledge related to the deep learning, because as I told you that if we are talking about the modern AI, right? So from 2000 to present. So in short, I can say here that it is an era of the deep learning. If I'm saying era, so it's a very huge word. It's a very like a heavy word, right? Era is not a simple word. So it's an era of the deep learning. Now, let me give you some achievement which a researcher has achieved in 2000s in the era of this deep learning. So the first was the 2006. The second was the 2012. I am highlighting some important year over here. The second was the 2014 and the 2014 again, right? The next one was the 2017, then 2018, right? Then 2019 and 2020, 21, and something like this. So let me highlight few points over here. So in the 2006, actually they were created the first deep neural network, that was the deep belief network. Okay, so this was the very deep network actually, which was solving, or which were processing a lots of data, right, in a single shot, and it was giving like a good accuracy as well. And here they were using the unsupervised technique also. You can simply search about deep belief network and you can read the detail about it. I'm not going into the detail of this like a different achievement of the deep learning, but yeah, I'm just giving you the overview over here. So here in 2012, actually the ImageNet competition had, ImageNet competition. So here actually in the ImageNet competition, so Jeffrey Hinton, the godfather of the AI, the godfather of the modern AI, he won this competition, and here they have invented the the architecture, the CNN architecture, which was very very powerful, okay, which was very very powerful. They have trained on the image and data set, and they got a tremendous accuracy over there. And here here the hardware wise also they were using the GPUs. They were not processing, or they were not training the model on top of the CPUs. They were using the GPUs also. So hardware wise, or the algorithm wise also, this was the very important year in the era of the deep learning. And from here itself the researcher got to know that, okay, if I want to train a huge model, so for that we'll have to changes in a hardware also. We'll have to use the GPUs, not even the CPUs. So here in 2014, why I have written two times. So the first 2014, it for the gains. So yes, the gains architecture has been introduced. So gains actually it plays a very important role for generating a data. So if you want to generate a data, right, so gains is not a new thing. It was invented in 2014, guys, and here this gains it plays a very important role if you want to generate a data. And here also we are using the fundamental unit of the deep learning, that is artificial neural network. So we have two part of the gains. So the first is called discriminator, and the second is called generator. The second is called generator, okay. And here this is responsible for generating the data. If you want to know more about the gains and all, so definitely I will record the specific video on top of it. In 2014, one more architecture. So this is related to the images. Now this is related to the sequence, or related to the text. Now here the architecture name was the encoder and decoder, and this plays a very important role, guys, in the field of generative AI. In future you will get to know that, right? And even this also gains also in 2017 you will find out the ULM fit. If I'm not wrong, then ULM fit was there. And in 2018 I think ULM fit was there. Then in 2018 transformer architecture was there, okay. And I think one more thing was there, I forgot to tell you that in 2016 maybe AlphaGo also there, AlphaGo, okay, AlphaGo. So AlphaGo is also there. This is a kind of application, you can search about it, you can read more about it, AlphaGo. And there heavily they were using the concept of the deep learning, right? Now in 2018 there was a transformer, guys, and it's I don't even have words for this architecture, transformer architecture. Primarily it has been created just for translating the languages, but later on this become a backbone of the modern or the state of art algorithm, whatever field, right? Whether it's a languages or images, for whatever, people are using this transformer now, and it's a very important thing. Now in the 2019 GPT is there, or bot is there in 2019 itself, okay. Here also I can write down the 90 exact. I'm not able to remember the year, but yeah, here I'm just giving you the overview of the modern AI. So these are the model, and this list is like a very huge, very long, right? This list and is like a very huge and very long. If you want to know more about it, I can create one dedicated video, but it is not about the deep learning history, it's about the generative AI history. So I want to keep it small only, fine. So here GPT was there, BERT was there, T5, okay. And in the history in the in the field of computer vision, like YOLO, SSD, okay, fast RCNN, faster RCNN, there are so many architecture which has been created. That's why I'm saying it's an era of the deep learning, it's an era of the vision and the NLP. So guys, I hope now you are clear from 1952 till 2024, and you got to know the meaning of this architecture also. So here this AI, so this AI means superset. Now here this machine learning also, it is belonging to the AI. Now here this deep learning also, it is belonging to the AI. And here this generative AI also, it is belonging to the AI itself. So somehow everything is AI, artificial intelligence. Now we have a different stages of the AI. So here between 1952, 1960, then 1962, 1970, right? Then 1970 to 1980, then here 80 to 90, then fifth one is 90 to 2000, and here so from 2000 to 2000 to present. So somewhere you will find out that this classical AI was dominating in this era. Then in the ML, actually this era was dedicated to ML, even this also, this particular era. Then in 1980 and in 1990 you will see the huge advancement in the deep learning also, and the present era is completely dedicated to the deep learning and the generative AI. Got it? So I hope till here everything is fine. Now let's talk about the generative AI. Specifically, we'll talk about the generative AI. So guys, whenever we are talking about the generative AI, so the first thing, what the first thing comes in your mind? The first thing comes in your mind, generative, which is generating something, the AI which is generating something. Now we have other side also, the other side of the generative AI, that is called discriminative AI, right? So first we'll try to understand the difference between discriminative AI and the generative AI, and then only the idea will be more clear to all of you. Now here guys, now here in the generative AI, so in the descriptive AI and the generative AI, so or we can say descriptive model on the in the generative model, what will be the difference? So one side I can write it down, the descriptive model, and the other side I can write generative model. Now guys, if you're talking about the generative model, I can write in a couple of name over here so that you will get a clear-cut idea. The first thing is let's say linear regression, or let's say here the second one is LSTM, or let's say the third one is any CNN architecture, you can say any one, or let's say here BGG, right? VGG, okay, or any CNN architecture, okay, directly, because here the concept of the transfer learning and all comes into the picture, so that I will discuss later on. So linear regression is there, LSTM is there, and the CNN is also there. So here I have written 3 model name. Now this all the model of the machine learning, whatever you have learned so far now, linear regression, logistic, SVM, ensemble method, or RNN, LSTM, and go decoder, or this one, the different CNN architecture, right? So this comes in under this descriptive model. Now why it is called a descriptive model? Because here guys, see, in the descriptive model there is 2 things. First thing is specific task, right? And the second is limited data. Okay, now I can give you one example. Let's say here I train this linear regression model on top of the data, right? So on top of the house price prediction data. What I want to do here, I want to predict the house. I want to predict the price of the house. Now here I have trained my model on top of this house price prediction data. Now let's say here I am doing a supervised learning. This prediction is nothing. This predicted variable is nothing. It's my target column. So this is my supervised learning. Now here guys, what I'm doing now, this is my model. Let's say here I have trained my model, and here what I'm doing, here I'm giving my data to my model, different feature basically, and based on that I'm predicting the price of the house, and it's a regression problem. This is the regression problem. Now let's say if I want to predict the price of the diamond, will I be able to do it? Can I do it over here? Let's say if I want to predict the price of the bike, can I do it over here? No. Why? Because the model has been trained for the specific data, right? Specific data and on a limited data. And here guys, here actually you will see we are doing a supervised learning. The learning method is supervised and the data is specific and the data is limited over here. Now here I can give you one more example. Let's say I am creating one more model. Let's say logistic regression is there. Now this model I have trained on top of the diabetes data, right? I want to check that whether a person is having diabetes or not based on a various feature over here, right? So based on a various feature I want to check that. But let's say if I want to detect that person is having malaria or not, in that case will be able to do it? No, it cannot do it, because the discrimination, okay, which we are doing based on a specific data or the limited data. Let's say the training is, which we are doing over here, that's a supervised training. Getting my point here? I think you are getting. So discrimination, whether it's yes or no, whether person having diabetes or not, we are doing a various feature, but we cannot do it for the malaria data or any other data set, pneumonia data. We only can check the diabetes over here. We can do the discrimination. Now let me give you the example related to this LSTM also. So let's say we have a LSTM model. Okay, this is my LSTM model. Now LSTM model, it's also called a memory unit. It's also called a model for the sequence data. So let's say here we are passing a let's say here I'm passing a sequence data, different feature. Okay, or what I can do here, I can take a single cell, or I can take the single input only, that is nothing, that is a sequence text. Okay, let's say there is a text sentiment, any sort of a text which is responsible for giving me a like a response, that is sentiment, right? So here also, so it's a sentiment, yes or no. Now the data basically which we are passing over here, it is a specific data related to that task only. Let's say I'm training my LSTM model on top of the Twitter data, right? Twitter data. Now can I do the same thing? Can I use the same model on the IMDb data for checking the good or bad review? No, it is not possible. We cannot do that. We cannot do that. So there is a issue over here. There is a problem. And same to CNN. Let's say I've created one CNN model, and here I'm checking whether the image is cat or dog. Now let's say I'm passing the image. So can I use the same CNN model? Can I use the same CNN model over here? Can I use the same CNN model for you and me also? No, I cannot do that. Why? Because this has been trained on a specific data, and that type of model is called classical model, discriminative model, predictive model, which is a little different compared to the generative model. Because in generative data, so let me talk about the generative model now. So in generative AI or in generative data, let's say this is my model. Now we are passing input to the model. So the first thing what it will do, it will generate a data, right? So data can be text data, the data can be image data, this data can be like video data, data can be audio data, anything you can generate by using this model. Now here the first thing, the data which we are using for the training, it's not a specific, it's a very huge, right? So huge data, we are using any type of data. The second is what, it is not for the specific task, it's a general model. It's a general model. So either it can be a general language model or general image model, or it can be both, diffusion model. Okay, so huge data and it's a general model, right? Any type of input we can give over here related to any type of task, related to any type of use case, and at the end it will generate the answer, right? And here the training process also, the training process. So we have two type of training. We have supervised training and we have unsupervised training. So guys, here we have supervised training, we have unsupervised training. We are using that only, but in a different manner, in a little different manner. For training this model, we are using a little different technique. So I will talk about it, what is that. So generative model is fine, and this discriminative model is fine, but our main agenda to understand about the generative model only. So related to the generative model, I would like to give you couple of name over here. Related to the generative model, I would like to give you the couple of name. So here guys, the first name which I would like to give to all of you, that is what, so that is a image to image generation. That is what, that is a image to image generation. The second thing, the second type of the generation is called, model is called text to text generation. The third type of model is called image to text generation. Okay, and the fourth type of model is called text to image generation. Okay, now this task, this is called homogeneous, because here actually what we are doing, we are passing the image to the model, and we are generating the image. And in this one also we are passing the text. Let's say we are passing the text here and we are generating a text. But here this is called heterogeneous task. Heterogeneous task means we are passing something else over here and we are generating something else from this model. Means we are passing this image and we are generating something else over here. We are generating the text, or we are passing the text over here and we are generating the image over here. That's it. Now guys, a few more things I would like to clear over here. So if you want to understand the basics of the generative AI, if you want to understand the fundamental of the generative AI, the fundamental model, the core model of the generative AI, which was the earliest one, the first thing which I would suggest you, learn something about gains, right? How the gains was working. The second thing I will discuss, I will tell you that learns about the auto encoder. This both actually, it's a ANN based technique, ANN based technique. And here we have one more technique of the auto encoder, that is called variational auto encoder. Variational auto encoder. Okay, auto encoder. So encoder. So here variational at on autoencoder, variational autoencoder, and this autoencoder again. So and this is based on an artificial network only. And we have one probabilistic method also, that is called a Markov model. So let me write it down over here. Markov model. Markov model actually, it's a probability based method. Probability based method, right? So this Markov model and this gains autoencoders, variational autoencoder. If you want to learn about the fundamental of the generative models, so please try to learn about this technique. And in the future class I will try to discuss it. Now here guys, we understood about the different generation model, different type of generation and all, and this is the fundamental of the generative model. Now here guys, let me talk about few more things. So initially I discussed that we have this artificial neural network, we have this CNN, convolution neural network, and we have this RNN, recurrent neural network, right? Now guys, this artificial neural network, it is specifically for the like a tabular data. So here we have a tabular data which is arranged in a row and column, right? So for that, now this convolution neural network, it for the images, for the image processing and all. Okay, now this RNN actually, it is for the sequence data. It is for the sequence data. Now guys, whenever we are talking about the deep learning, okay, whenever we are talking about the deep learning, so always this ANN, CNN and RNN comes into the picture. Okay, now here deep learning, or if we are talking about this generative AI, right? So here this we are talking about the deep learning, so RNN, CNN and RN and this RNN comes into the picture, or whether we are talking about the generative AI, right? So yes, this will be the fundamental of it. Now okay, so let me remove the generative AI from here because it might be the confusing. Now if we are talking about the deep learning here, so unstructured data is the one of the thing over here. So unstructured data means what? Unstructured data means images and the text. Okay, just focus on two things, images and text, right? So here guys, one thing is image and one thing is text. So this CNN model actually, it is for the images, right? CNN model, it is for the images. It is also called the image models, image based model. So here we have many more model, like, so the model name which I can write it down over here, that was the VGG model was there, and ResNet model was there, and then here Inception model was there, right? Then this model for the image classification, the fundamental task of the CNN, right? So the fundamental task of the CNN is nothing, image classification. So this is the model for the image classification. Now we have some advanced tasks also, so detection. So for the detection, actually you will find out the YOLO, you will find out the SSD, you will find out the RCNN, faster RCNN, okay, faster RCNN. So this is the model for the detection, object detection, whether the object is, where the object is present in the image, we can detect it. Now here the fifth one for the segmentation, like we have detectron, okay, detectron, we have fast RC, like we have a variant of the RCNN itself. So mask RCNN is there, correct, mask RCNN. We have UNet, VNet, okay, UVNet. So this is for the segmentation. Likewise, we have OCR tracking and all. So this is the task of the and this all comes inside the vision, actually, vision, okay, vision. And this is called, so here this YOLO, SSD and this type of model, actually it has been trained on a huge amount of data. So directly we can download the weight of it, and directly we can download the weights of it, and then we can train our model, right? So we can directly we can download the weight and we can use it. That is called transfer learning, or we can fine tune it. Okay, we can fine tune it on our requirement also, right? So this is this has been trained on a huge amount of data, on different type of data like ImageNet and all. And here this type of model is called visual model, okay, vision based model or visual model, vision based model, right? Vision based model. Now this is specifically for the images and for the videos. Now here we have one more thing, that is what? That is a NLP, right? NLP. Now in the NLP, actually we have a different tasks, right? The first task which I'm writing over here, and generally we are dealing with the text data over here, text data, audio, which is related to the sequence, any type of sequence. Okay, now here guys, this is called vision based model, or this is also called visual model, anything you can say, and you can see, or here I can search about the large visual model. So what I can do in front of you only, I can search about the large visual models, right? Large visual model. So here guys, you will find out the like a GitHubs and all. So let me show you this particular which one is there. So just a second, let me check with any of the link. Basically you will get to know about the large language model. So here guys, you can see Google Vision Transformer. I will come to this Vision Transformer and all, don't worry. And here this is the large language model. Okay, wait guys, let me check once with the large language model if I can find out something for all of you. And okay, large image model. So yes guys, so here you can see this is the website, papers with code. Actually this papers with code, let me show you to all of you. I think then you will get a clear cut idea. See guys, this one. So this papers with code, actually it's a very good website. There you will find out like so many research paper and all. Now I just search about the image model. So these are the image model, all the image model you will find out over here, right? You will find out over here all the type of the image model, right? So see, PocketNet and DeepSim, CB, these are the some state of art model, basically, which is has been taken a huge amount of data for the images, okay, for the image related tasks. Now here guys, I think you got to know about the images. Now if we are talking about the NLP, so we have the like a different task in the NLP. So we have the task like text classification. Text classification is there. We have another task, let's say image okay, not text generation is there, not image, basically text generation is there. Now here's the third one, basically a chatbot is there, that is comes inside the conversational AI. Now we have the another one. So here the fourth one is, I can write it down over here, that is text summarizer, right? Text summarizer. And here I can write it down the next one. So summarizer, ZIOR, summarizer. Okay, now here the next one which I can write down, text summarizer, and question answering is there, right? So these are some tasks, actually question answering and all. So these are the tasks which you will find out. Now see, text classification, text generation, chatbot, text summarizer, and the question answering. So for like solving this type of task, actually we came up with the RNN. This RNN, actually it's a sequence based model, right? Sequence based model, which is like responsible for processing the sequence. Now here we came up with the one more update on top of the RNN, that was the memory unit, that was called the memory unit. And that the name was nothing, the name was the LSTM. And then we were having one more architecture on top of the LSTM, that was a GRU. So we're using this RNN, LSTM, and GRU for these type of tasks, right? For these type of tasks. Now here guys, see, for the images we are having the different model, and for the like a text, right, for the sequence, actually we are having the different model. But the thing got changed, okay, but the thing got changed recently. From where? How? So the thing got changed because of this transformer, right? Because of this transformer, the things got changed. See, before we were using this CNN model, the different CNN model for the images, and the language model. This is called language model, actually, because here we are training on some sort of a sequence, some sort of a data, and we are trying to predict something. So this is called a language model, and this is called visual model, right? But the thing got changed after the transformer. Actually they created a transformer. Actually this transformer, see, we have vision. First thing we have a vision, and the second thing we have a images, right? Sorry, this text or the sequence. Now here if you want to combine it, so you will find out the combination of it also. So the combination, the task like image captioning and all, image captioning, video analysis and all. So before we were doing this type of task, image captioning and the like a video analysis and all, right? So for that, okay, so for the image captioning, video analysis, we are using the image based model, like we were using the CNN or the different variant of the CNN, and we were using the RNN or the different variant of the RNN, like LSTM, bidirectional RNN, bidirectional STM, or the GRU. But the thing got changed, the recent history of the AI, the recent era of the AI, right? It got changed, and that is called a generative AI. And because of what, guys? Tell me, because of what? Because of the transformer, because of this particular architecture. Even though this architecture does not belong to the vision, right? Earlier, the architecture, when they have released this particular architecture, this was not belonging to the vision. Specifically, it was the sequence only. And you will find out this transformer actually, it belonged to the RNN history, RNN, then LSTM, right? This encoder. I will come to that. Don't worry. In detailed way, I will explain you. Encoder, decoder, right? And then like there was the attention was there, and then there is a transformer. So after the transformer, the thing got changed suddenly. Now here, guys, see whether the task is related to the languages, right? Languages, or whether the task related to the vision, right? Everything we can do by using this transformer, right? As a base architecture, I can use the transformer. So whether there is a homogeneous task, homogeneous means what? Tell me, guys. Here, homogeneous means image to image. Earlier we were using the gens for this one, for the image to image, auto encoders also, or text to text, right? Text to text, we can do it by using the transformer. And the heterogeneous task also means image to text and text to image. So first, guys, we'll try to understand about this text, right? So first we'll try to like understand about the text, and we'll try to understand about the language modeling. Not only the language modeling, we'll try to understand about the large language modeling, that is called LLM. And as a base architecture, they were using the transformer. Getting my point? Yes or no? So here we talk about the LLM. By using the LLM, what we are doing, we are trying to achieve the generative AI. We are generating something. What we are generating? We are passing the text, right? We are passing the text to my model. And here we are generating a text from the model. Now this, so here this LLMs, right? This LLM, but this LLM, this large language model, now become too much powerful. Okay, the latest model of the LLMs and all. So the earlier model was the LLM was like GPT, right? BERT was there, T5 was there, which specifically was the language. But now the transformer, like a transformer model which is coming, like GPT B4, okay, GPT 4, or GPT 4B, or Gemini model, or like a different other model, or diffusion model like DALI, Mid Journey, or Donut, or like Jurassic, right? So see, these are the model. It is able to do the language task and the vision task. Why? Because of the capability of the transformer. Now this one, DALI, Mid Journey, Donut, so this is for text to image or image to text. This is also called a diffusion model. What is a diffusion model? Here, tell me. Where we are doing a heterogeneous task. Homogeneous task means image to image, text to text, which we are able to do by using this particular model, right? And we are able to do this task also, heterogeneous task also, by using this diffusion model. Specifically for this diffusion model we can use for the homogeneous task. Diffusion model means vision plus sequence. Okay, I hope you are getting it. So now I think you got to know the different type of generation. You got to know the transformer, the importance of the transformer. You understand about the language modeling, right? And in next class, actually, I will start my discussion from the language modeling itself, and then we'll talk about the RNN, LSTM, and the evaluation of this language modeling, evaluation of the generative AI. Then we'll come to the diffusion model, and then we'll come to the chat GPT, right? So thank you, guys. Thank you for watching this video. I know it's quite long, but I have provided you too much information. So please try to watch the complete video, and in the next video, in the part 2, we'll try to discuss few more things, and then we'll start with the practical implementation, right? So thank you, guys. Thank you. Bye bye. Take care.